Alright, Advanced 7th, let's get going today. 1.1c, solving multi-step linear equations. But as always, guys, before we get started, make sure you like, make sure you subscribe, and make sure you guys ring that notification bell so you guys can see these videos as soon as they come out. So, in this lesson up to this point, or in the lessons up to this point, we've been working with expressions. We've reviewed how to simplify a linear expression and how to evaluate a linear expression for a given value of x. So now we're going to begin to solve linear equations. So our task is to find the values of the unknown that make it true. So Damien and his friends went trick-or-treating, because who doesn't love to go trick-or-treating and get as much candy as you can? The next day, they got together and counted their candy. Damien had twice as much candy as Nick, and Bo had 10 more pieces than Damien. So we created a model for this. So this right here, this number C, is going to be Nick. We know that because Damien has twice as much. And as we're going to see, this right here is 2C. So this has to be Damien. And because we're comparing all of this to Nick, that's why we know Nick has C. And then Bo had 10 more. So Bo had 2C plus 10. So now we showed on the model where each of these belong to. So now the C over here, we have Nick, which is represented by C. Damien is represented by the 2C. And Bo is represented by the 2C plus 10. But now what if, just think for a second, what if we knew that altogether the boys had 230 pieces of candy? Well, then we can create a model for this. Right here, that's the model. So the whole thing is 230, but we're still using that linear expression to model it, because we don't know what C is. So we know that these are both linear expressions that represent the amount of candy the boys have together. When we set two linear expressions equal to each other, we create a linear equation, because we now have equality. We are asserting, or stating, or saying, or telling that the two expressions are equal to each other. We know this for a fact. This isn't something we're guessing. We know this for a fact. So using the candy example, we can create the following equation. C plus 2C plus 2C plus 10 is equal to 230. So the way we're going to do this, the way we're going to model this, is we're going to use this model up here. All right, so we have 5 C's. 1, 2, 3, 4. Oh, those are terrible. C, 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 C. Plus 10 is equal to, and I'm going to draw just a big bar here and put 230. So in this context, C is our pieces of candy. So C are the pieces of candy. I think I spelled that wrong. No, I didn't spell it wrong. Good. It looks funny. Pieces of candy. But it's not just, it's whose candy? Because it's not just pieces of candy, because we know there's 230 pieces of candy. It's the pieces of candy that Nick has. Because remember, guys, this is all in relation to Nick. Because you said Damien has twice as much, and Bo has 10 more than Damien. So Bo has 10 more than 2 times the amount of candy that Nick has. This is all dependent on Nick. So now we're actually going to solve this equation here. And what we're going to do is we're going to follow some steps. So I'm going to come over here to the right, and I'm going to write this equation out. So we have C plus 2C plus 2C plus 10 equals, and I'm going to come over here, 230. So now we have these rules. All right. So the first thing we're going to do, if it's applicable, if we have to, step 1 is distribute. Now that would mean if we had like a 3 on the outside here, but we don't. So we have nothing to distribute. right now. So step 1 is done. Step 2 is combine like terms. And what that means is we need to get into that simplified form, that we need to get this into something like ax plus b equals cx plus d. We need to get to look something like that. So let's combine our c's on this left side. So 1 plus 2 plus 2 is 5. So we have 5c plus 10 is equal to, and we're left with just 230 over here. Step 3 is we're going to subtract. We're going to move constants. So the things that don't have a variable on them are what's called a constant. No matter what c is, they don't change. So we need to move our constants to be on the same side. So we need to move this 10 to the right side. So to do that, we're going to subtract 10, which means that we have 5c is equal to 220. Step 4 is to move variables. Now, since we don't have any variables on the other side, we don't have to do this yet. Actually, I switched those up. Sorry, guys. Step 3 is move variables. Step 4 is move constants. And then step 5 is divide. So now we just need to divide both sides by 5 in order to get the c by itself, which gives us that c is equal to, ooh man, this is a really, really tough one. All right, if you guys want to do this in your heads, a quick way to do it is to break it up. How many times does, what is 200 divided by 5? Well, 20 divided by 5 is 4, so this has to be 40. And then 20 divided by 5 is 4, which means we're going to get 44. So each kid has 44 pieces of candy. C equals 44, which means that Nick has 44 pieces of candy. Damien has 88, and Bo has 98 pieces of candy. Because remember, we had to put it back into the equation, right? We had to put it back into that expression. So remember, this was Nick. He has C. Damien was 2C. And Bo was 2C plus 10. So we need to go back and backfill or back solve and plug this back in. So a solution to an equation is a number that makes the equation true when substituted for the unknown. In this example, the solution is 44. We can verify that all we want to. We can plug 44 back in, and no matter what we do, we're going to get 230. It's important to note that when we create an equation, the two expressions on either side of the equal sign must be true for one value of x, no values of x, or all values of x. Okay? So it's going to be one of these things. If it's true for one value of x, we'll get one solution there, just like we did with the candy problem. C had to be 44. There was no other thing it could be. If we get no values of x, there is not a single number that can be substituted for the variable that makes that equation true, meaning we have a false equation, or we did something wrong. Now, there will be times when you guys will have no values of x, and we're going to get there, and it's super cool when we get there, guys. Trust me. It is like one of the most fun things that we do in this class. No values of x. Now, all values of x means that no matter what number we substitute in for that variable, it's always going to be true. These are some really cool things that we're going to get into, especially with systems of equations. So now we're going to look at a lot of equations that have one solution for now. We will look at some that have none and all. It's going to be a lot of fun, guys. Trust me. So I'm going to model this one for you guys. Okay. So the following is a model for the equation 5x minus 8 minus 2x equals 4. Create this model in your tiles and solve the equation showing the solving actions steps below. So here's our model, all right, and here's our equation. So step 1, distribute. We can't distribute. We don't have anything to distribute. Step 2, let's combine our like terms. So step 1, distribute. Done. Can't do it. Step 2, combine like terms. So then 5x and negative 2x, 5 minus 2 is 3, so we have 3x minus 8 equals 4. Done. Step 3, move variables. Well, we don't have to move our variables because there's none on the right side. Step 4, move constant. Okay, so we need to move this 8 to the right side. So to get rid of a negative 8, we need to add 8 to both sides. So then we get 3x is equal to 12. And our last step, divide. 3x divided by 3 gets us x. And 12 divided by 3 gets us 4. So x is going to equal 4. So now we need to verify that. We need to make sure this is true. We're going to plug it back in for x and see what happens. Well, 5 times 4 minus 8 minus 2 times 4, does that equal 4? I'm going to put a little question mark there because I'm not sure. Well, 5 times 4, that's 20. Minus 8 minus 8. Okay, so 20 minus 8, that's 12. And 12 minus 8, that equals 4. So we are good to go. That was perfect. So now we're going to model and solve these equations. So I'm going to do one of these for you guys, and I want you guys to do the rest. I'll do more in class, but I want to do one in this video. So let's work on this one over here. 4x plus 3x minus 1 equals 6. And now when you guys are modeling this, you guys can draw these on just some scratch paper. You guys don't have to draw them if you don't want to. If the steps make sense to you and it makes more sense that way, do it that way. But if you need to model it to get it where you want it, then do that. All right, so let me show you guys how to model this one first, just to show you. So we have 4x, I'm going to do it off to the side. 4x plus 3x minus 1 is equal to 6. So if we look back up here, how they did it is they divided it into two little sections. So that's what we're going to do. So we're going to have a 4x, 2, 3, 4, plus 3x, 1, 2, 3, minus 1. We have a little 1 square that we're shading in, is equal to 6. 1, 2, 3, 4, 5, 6. So that's what your model should look like, guys. All right. You're looking at how many x bars we have, how many negative x bars we have. how many 1 squares we have, and how many negative 1 squares we have. So then from there, I'm going to come over here, and I'm going to do my 5 steps. Can we distribute here? No, we can't. So let's combine our like terms. So we get 7x minus 1 is equal to 6. Do we have to move our variables? No, we don't have to move our variable. So let's move our constant. Plus 1, plus 1. We're going to get 7x is equal to 7. And then our last step is just to divide. So x is equal to 1. And that's it, guys. That's really it for solving these. There's not too much involved in this right now. And if you guys want to double check it, we can. Let's go over here and let's say that these are 1s. So we have 1, 1, 1, 1, 1, 1, 1. So we have 1, 2, 3, 4, 5, 6, 7. Minus 1 is 6. So 6 equals 6, and we're good to go. And then I want you guys to try these ones on your own. You guys got this. Trust me. You guys can do this. I know you guys can. It's not too bad at all. All right. So number 7, the following is a model of an equation. Write the symbolic representation or the equation for this model. So how many x bars do we have? So we have 3x plus another x plus 1, 2, 3, 4, 5, 6 is equal to 2. So now we're going to solve this equation. Again, step 1 is distribute. We can't distribute here. Step 2 is to combine our like terms. So let's combine our like terms. We're going to get 4x plus 6 is equal to 2. So now move our variables. We don't have to move variables because we don't have a variable on the other side. Move our constant. We're going to have to subtract 6 from both sides. So that leaves us with 4x is equal to negative 4. And finally, our last step is to divide. 4x divided by 4 is just x. And negative 4 divided by 4 is going to get us negative 1. Don't forget that negative, guys. That negative is very important. Okay? That negative is extremely important. You guys cannot forget that. So now we're going to solve the following. I'm going to solve one of the tougher ones here for you guys. Okay? At least I think I am. I forgot which ones we talked about doing. Oh well. I'm going to solve one of the tougher ones here for you guys. I'm going to solve number 11. Okay? So number 11, let's combine our like terms. We're done. Or let's distribute. We don't have to distribute. Number 2 is to combine our like terms. Our like terms are already combined for us. Man, this is easy. Step 3 is to move our variable. Well, we don't have to move our variable. Step 4, move our constant. How are we going to get rid of that negative 4/3? I think what we should do is add 4/3, maybe? Do you guys agree with that? I think that sounds right. I don't know, man. I'm getting so confused. This one's just... Ugh. This is the toughest math problem I've done in years. Okay. So 4/3 minus 2/3 is going to get us a 2/3. Perfect. Is equal to 6r. Alright, guys. I have a little joke to throw in there. Why couldn't the little kid go in to see the pirate movie? Because it was rated R. Oh, man, I cracked myself up. Okay, step 5 is to divide. Oh, man. This one really is tough. What's 2/3 divided by 6? Oh, if only I could remember. So, guys, there's a really quick way to do this, actually. So, 2/3 divided by 6, right? Well, that's the same thing. This is the same thing as saying we have 2/3 times 1/6. All right? Now, you may be wondering, Mr. Lynch, how did you get there? Well, if we have a 1 over here, right? So let's say 2/3 is equal to something times 6, right? Well, the only way... What am I doing? Why won't my pen just work? Well, let's think about this. The way to do this is to divide, right? Well, then, if we were to divide by 2/3 and get everything on this side, well, that's the same thing as multiplying by 3/2. Because watch this. That becomes a 1. That becomes 6 over 6, which is 1. And if we take 2/3 and divide by 2/3, anything divided by itself is 1. So we're going to learn this fancy new thing here called multiplying by the reciprocal. This is one of the best things that will help you guys in math. If we divide a fraction by something, we're going to take that something on the bottom and we're going to flip it. So 6 over 6 is equal to 6 over 1. All right, and if we're going to flip it, it's going to become 1/6. And then we're just going to multiply straight across. So this is going to be 2 over 18, or 1/9. So 1/9 is equal to our R. RR. Get it? RR. All right, and then spot the mistake, guys. Ricardo solved this problem incorrectly. Circle the mistake and describe the mistake in words, then solve the equation correctly. What I want you guys to do is to do this and come to class ready for that, all right? I think you guys can do this. All right, 24. Carson and his family drove to Disneyland. They started on Thursday and stopped for the night. On Friday, they drove twice as many miles as they had on Thursday. On Saturday, they drove 50 more miles than they had on Friday. Carson's mom asked him to write an equation to determine how many miles they drove each day. So Carson wrote the following equation, M. And guys, remember, M is miles driven on Thursday. Because remember, this is all in relation to Thursday. They started on Thursday and then stopped for the night. On Friday, they drove twice as many miles as they did on Thursday. And on Saturday, they drove 50 more miles than the previous day. So match the expression with what it represents. The number of miles driven on Friday. I don't know. The number of miles driven on Saturday? Total number of miles driven. Oh, we just figured that out here. Look, M is the miles driven on Thursday. So we're going to connect these. These two are connected. So then on Friday, they drove twice as many miles as they had on Thursday. So the number of miles driven on Friday has to be that 2M. And I'm going to leave the rest of this for you. Don't worry about the story. We're going to do some of these first row ones here. All right, these first columns. So I'm going to start it off easy with you guys. I'm not going to do number 1 because I think you guys can do number 1 on your own. I'm going to go with number 4 because this one's a little trickier. So again, first step is to distribute. Well, we have nothing to distribute. So let's combine our like terms. We have an A and an A. So 5A minus 2A gets us 3A plus 8 is equal to -7. Okay. So then let's move our variables. We don't have to do that. We don't have a variable on the right side. Let's move our constants. So in order to get this away from the A, we need to subtract 8 from both sides. So then we get 3A is equal to -15. And of course, our last step is to divide. 3A divided by 3 is just A. -15 divided by 3 is -5. I believe you guys can do 7. I'm going to do one of the harder ones. I'm going to do 16. Okay? So, again, Check for distribution. We don't have to distribute here, so we're fine. Check for combining like terms. We do need to combine our like terms. 0.4 plus 0.1 is 0.5y equals negative 2.5. Move our variables. We don't need to move our variable. We don't have any constants to move, so our last step is to divide. So we're going to divide both sides by 0.5. So that means that y is equal to, oh man, this is a head scratcher. This is a real head scratcher here. So guys, do you see that the decimal is in the same place on both of these? We have negative 2.5 divided by 0.5. See where the decimal is on both of those? Well, an easy way to do this is to move the decimal one place to the right. This is the same as asking what's negative 25 divided by 5. Well, that's easier. That's negative 5. So then this up here must also be negative 5. So y has to be negative 5. Is that making sense to you guys? I really hope it is. So guys, this is the first video for you guys for the week. There will be another video coming out for lesson 1.1D. Be watching for that, guys. As always, make sure you hit like, make sure you subscribe, and make sure you guys ring that notification bell so you guys can get notified of these videos as soon as they come out. As always, guys, have a great weekend and have a great week at school. It's going to be a blast to see you guys again.